In this video, we're going to look at some examples of the various types of transformations that we are going to do for or to the rational equation. If you look up at the top of the note sheet here, it says g of x is equal to, and it's got the transformation function for all the possibilities for what A can do, B, C, and D can do. And we are doing transformations on the rational function f of x is equal to 1 over x. So if we want to change the A value, those are going to be your vertical stretches, your vertical compression, and reflecting over the x-axis. So vertical stretch, we're going to pick any value of A that is greater than 1. Doesn't matter what it is, decimals, fractions, anything, whole number greater than 1. So let's say, I don't know what I'm trying to hit down here, but my hand keeps hitting my different buttons. So let's say g of x is equal to, let's pick an A value of, 12 over x. Okay, this 12 would create a vertical stretch 12 times away from the x-axis in both either positive or negative direction. So that's a vertical stretch. A vertical compression is an A value that is between 0 and 1. So A has to be greater than 0 but less than 1. So generally think of your decimal values, your fractional values, but again, keep those fractions and decimals between 0 and 1. So if we did, let's say g of x is equal to 0.2, okay, 0.2 is between 0 and 1 over x, that would be a vertical compression. You would be compressing all of your points closer to the x-axis. All right, reflection over the x-axis, your A value, value, that is a horrible right. Let's try that again. A value is negative. Now, to keep it simple, I'm just going to make it a -1 for this example. So if g of x was equal to -1 over x, that way you can obviously do a reflection along with a stretch or a compression, but that reflection is just this negative means that you are going to reflect over the x-axis. Okay. So those are all the possibilities for what happens for your A value. For your B value, those are going to be your horizontal stretch, your horizontal compression, and a reflection over the y-axis. All of these changes are going to directly happen to x. So if you look at this function, right, it was b times x. So let's go ahead and show that. So for a horizontal stretch, I need my b value to be between 0 and 1. Kind of weird, I know, but that's how we're going to stretch. So if we do g of x is equal to 1 over, let's say 0.5x, that is actually a horizontal stretch away from the y-axis, okay? Now, a horizontal compression is a b value that is going to be greater than 1. So g of x is equal to 1 over 3x. That's going to be some kind of a horizontal compression closer to the y-axis. So that would be your horizontal. Last but not least is the reflection over the y-axis. That is a b value that is negative. And to keep it simple, again, I'm just going to make the b value a -1 in this case, so that way we're not kind of confusing it with either the compressions or the stretches. Sorry for the pause there. I wanted to make sure I was getting my words right. So if we make the x down here negative, that's going to be a reflection over the y-axis, as I'm drawing in extra stuff. All right, so changes to the C value are going to create a horizontal shift left or right. Those are going to change either the domain or the range, and we'll talk about if it's related to the vertical or horizontal asymptotes like we did a little bit in the last video. Actually, would have been 2 videos ago. So let's start with the horizontal shift to the left. That's going to be where we want to add positive c to x. Okay, so that's going to be any positive value added to x. So let's say we do x plus 6. Adding 6 to x is actually going to shift this thing to the left 6 units, okay? Horizontal shift to the right, we're going to, let me put this down right, subtract a positive, I keep adding extra little letters in here. Let's try that again. Positive, positive c to x. But this time we're going to subtract. So let's say we do g of x is equal to 1 over x minus 7. So subtracting 7 from x is actually going to push this graph to the right 7 units. So horizontal changes are related to the vertical asymptote. And because they're related to your vertical asymptotes, that is going to change your domain values. So whatever values you find for your vertical asymptotes, those are the ones that you throw out of the domain, and that's going to be found by these denominators. All right, last set here is what happens when we adjust D. So let's see. If we do, vertical shift up, if we add a positive D value, okay, and that's going to be to the function. If you look here, right, this whole thing, we've got this big old fraction, and then we have a random plus D at the end of it. That's going to affect your vertical shifts. So if we add a positive D, that might look like g of x is equal to 1 over x plus, 18. All right, it doesn't matter what you're adding. If you're adding anything, that is going to be a vertical shift up. Vertical shift down, you're going to subtract a positive D value, again, from the fraction. So g of x is equal to 1 over x minus, 57. All right. They can be ridiculous numbers here. It doesn't matter. This would be a vertical shift down. So vertical shifts are going to be related to your horizontal asymptotes. And if they're related to your horizontal asymptotes, that's related to range. All right. So these are just examples. Now, any of these examples, you could have your own favorite numbers in there, but make sure you understand which pieces are related to the stretches, the compressions, the shift left and the shift right, along with the reflections over both the X and Y axis. If you've got any questions or concerns on any of these examples, or if your examples would also work, please let me know.